Well, I have told the basic process of the tragedy of commons, which basically claims that when you have multiple people using the same resource, actually that resource will deplete because everyone basically will, um, for everyone, the cost of using that resource, uh, uh, the benefit of using that resource is personal. However, the cost of depletion created by their use is small, and it's actually that cost was shared by everyone. But if everyone basically uses that resource, that basically means that would basically mean that that resource, uh, the cost for everyone will be really high. But that cost basically, individual cost people face is actually some of the cost created by usage of everyone together, not their own individual cost. In this case, the tragedy of commons assumes that the people cannot coordinate with each other, or the coordination of the people, if you want to achieve that, it has other harms in the economy, which might be which might have worse outcomes. So, how do you solve the tragedy of commons without coordinating the people? You just give property rights of the commons to someone else. So, the commons will become private property, the pasture, for example, and that the owner of the pasture will decide how to use that pasture. So this idea was used pretty much to privatize the pastures, and many of those pastures, by the way, were used as mines, so they were not protected as pastures at least. Um, some of them were protected, uh, uh, but well, this is basically the way tragedy of commons is described. So if you have uncoordinated individuals that are using a common resource, they might deplete that resource. What is the solution? Well, unless you can make that natural resource a private property of someone, there is no solution. If you are talking on whole atmosphere or whole ocean or sea, well, even a lake in many cases, it is not easy to make that a private property, of course, at least at this point. Um, so it's interestingly, it says the tragedy of commons itself describes market mechanism might not solve any kind of even resource extraction problem, let alone waste extraction problem. Uh, well, however, the way uh, the this problem might be solved is somehow you need to internalize, make each actor that is using the resource to internalize the cost. For example, if I produce the waste and if the cost of that waste production is shared by everyone, somehow I should calculate this cost and make the person who is actually um, extracting that waste to pay for that the cost its waste is creating in monetary form, of course. And of course, in this case, monetary calculation of this cost can be a problematic thing. And at political sphere, especially at the time of the crisis, the people might be against these type of additional payments made by the companies, especially at the time when companies are actually companies leave problems of being, I mean, being bankrupt. But interestingly, those are the exact times when companies could make drastic changes in their production methods to decrease the waste production. And exactly at that times, the calls will be made to decrease the the additional payments that are paid to make the companies internalize the cost. So this internalizing the cost is usually made artificially, and there should be at least an authority to calculate. I mean, how the monetary value of this total social cost created. So we might ask whether basically we might make actually the problem of markets where well, we might state that it's very close to the typical prisoner's lemma problem, where basically we have different actors here. in most basic business now you have two actors, but you could easily have multiple actors, and if basically both act in one way, everyone will be better off in way A, basically. Put a limit in their pollution, for example. But if one of them pollutes less, but everyone pollutes, basically, the one that pollutes less will gain nothing, will be worse off even in the short run. The others will be better, kind of better off, because they, at least if they cannot reduce the pollution, at least they can get rid of a competitor in the market. But if all of the actors are actually polluting, then everyone will be worse off compared with the case everyone is polluting. But basically, when everyone acts according to their interests, when they cannot for their own interests, every time, I mean, if everyone doesn't pollute, but one company or one country pollutes, basically, this will benefit that country and still not harm the environment that much. So self-interest always calls you to deflect, to cheat, basically, to act against the common interest, basically. And that's the global prisoner's dilemma. To prevent everyone to get social inferior but individually better solution, all of these things show that, well, there might be need for coordination. So if waste side problem or resource side problem exists, again, to detect their existence, we need other sciences, natural sciences. But if they exist, almost all economics, I mean, including classical economics, show that a kind of coordination is necessary. So, what can be, I mean, reducing pollution can be done by reducing the production, but also developing necessary technologies, for which we also need incentive, by the way. So what can we do to reduce the pollution? Well, we can reduce or limit GDP, as you see here, and you can see, I mean, this is the idea of this is actually a graph of the people who are defending negative growth. They say up to a certain point, having more GDP is actually will benefit people, and up to a certain point, its costs are relatively small, but its benefits are large. But at a certain point, the cost of having producing additional output will increase, while the benefits of it will decrease. So at that point, you should basically stop. I mean, your production level should be the same, but the quality of the production, I mean, the amount, the composition, what you produce might change, but your production level, you should not have a higher production level in terms of physical sense, at least. But if you don't have physical sense of in physical sense of more products, it might be very much possible. I mean, a small computer which may need less resources to produce might cost more than 19th century. Might cost more in terms of its monetary value in today's sense, compared with maybe ships of the 19th or 18th century. I don't know, maybe not, maybe they might cost. So it might be possible to produce more expensive and useful products with less resources, maybe. And that possibility is actually, I mean, you increase the production, but in the most part of the story, even though resources, sometimes more resource efficient models, production methods are found, mostly as consumption or production level increase, that also increase the resource use, although maybe not as high as the consumption increase in production level, because I mean that could be more efficient methods could have been found, but if there can if a certain type of if a new trend of consumption increase or production level increase can be created, which doesn't increase the energy or material use use basically. If while energy or material use remains constant or even decrease while production level is increasing, in that case, of course, this will also create a sustainable case, sustainable economy. Well, whether this decoupling is possible is a big question. It can be maybe reached by changing composition of the consumption and producing things that needs less energy or material. But whether that can be done ultimately to change this trend completely or whether it has limits is a big question. For example, can we decrease our consumption of clothing or consumption of, I don't know, furniture? That can be an important question to ask, basically. And then we might have technological options, which might basically find technology so that that would require less energy and even less material in consumption of goods and production of goods and services. And technology can be one way of also creating this decoupling. But technology has certain limits. The first limit is created by the Jevons paradox, basically. The Jevons paradox is basically, it is explained that when you decrease basically the need for a resource in the economy, or the resource used for production in economy in general by a technological development, this is likely to increase the production level in the economy, and it will increase production of the. It might very well increase production level of the economy, so that in return, actually, you have decreased per unit production, the resource use or the waste extraction per product that is used, but basically the increase in the production level might outpace or dominate the effect created by this decrease in per unit waste disposal or resource use or per unit effect. So in general, basically, actually, the waste disposal or resource extraction problem might get worse, basically. So this is Jevons paradox. This is the case when you have an elastic demand, which basically means that when you decrease the cost, demand increases a lot. And in general, Jevons argues this type of demand exists in the overall economy, basically. Whether it exists or not can be tested. And then there is this option of the renewable energy. I mean, at least for the energy, you might use energy forms which won't deplete in a day, but which can renew themselves and become always available, like wind and solar energy and some other forms. But we should also note here entropy comes to the place. Every day, sun is actually sending to the earth energy, and that increase the usable energy forms on the earth. In the end, in order to keep the usable energy in the earth constant, the energy we use should not exceed the energy that is sent by the sun. And I pretty much include also the energy used by the nature. So when we use energy ourselves, we might basically decrease the energy that is usable by the plants. Although most of the energy that is sent by the sun is anyway sent away sent away to the space by reflection. So there is much more energy that can be used without endangering the nature, basically. But we should note that in the end, energy that could be used by everyone on the earth is fixed without decreasing the usable energy available on the Earth.